Hey calculus, welcome back. Our objective today is going to be to find intervals of increasing and decreasing by hand. I've got the checklist on the screen. You know what to do from here. So I guess Donnie's going to be learning some calculus with us today too. So you don't need to copy anything on the screen. I just want you to kind of notice what we're going to be looking at today, and notice that each relative min and max is followed by a change in direction. In other words, to create a min or max, you have to have a switch from increasing to decreasing, right? So that is what we're going to be looking at quite a bit this week. And you've done this, in Algebra 2 and Pre-Calc, but you typically would be given the graph or given a calculator. And we're going to learn how to do this just looking at the calculus. So quick question before we get started. I've got two lines. Which line is increasing? Which line is decreasing? And how do you know? So the one on the left is increasing because it has a positive slope, right? And the one on the right is decreasing because it has a negative slope, okay? So what in calculus gives me slope? Derivative, yeah. So remember, we're going to tie three ideas together: slope, derivative, and rate of change. So really tie those together as synonyms in your mind. So would you go ahead and pause your screen, and then we will fill this in together. So go ahead and pause. Okay, we are back. So this is really important. When the derivative is positive, and remember we're tying the word slope to derivative, right? On some interval x equals a to x equals b, then f is going to be what, do you think there? F is going to be increasing on that interval. And conversely, if the first derivative is negative on an interval, then f is decreasing on that interval a to b. And if the derivative, the slope, is 0, then the function is constant on that interval, okay? And then this next definition is really important by Donnie. F can change direction only when f prime is 0 or undefined, D and E. And we call those values critical points, okay? So please make sure you have that definition in your notes. All right, so let's use this information and see if we can find where f is increasing or decreasing by hand. So please write this. To find where f is increasing or decreasing, 2 steps. The first is we're going to find the critical points. And look at your notes that you just wrote. Hopefully critical points are where, this is very important, f prime is 0 or f prime does not exist, okay? The second thing we're going to do is make a number line with those critical points. And we're going to label the number line f prime and f, okay? And this will make more sense once we do a couple examples, but please make sure you have this strategy in your notes, and then we'll try some together. Okay, would you write this function in your notes, please? F of x is x cubed minus 3 over 2x squared. All right, so the first step was to find the critical points, and that's where f prime is 0 or D and E, right? So go ahead and find the derivative for me and hit continue when you are ready to check your derivative. All right, hopefully this is what you got. We want the critical point, so we want to know where this is 0 or D and E. This is not a rational function, so I don't have any denominators. So this is never going to be D and E, so I will just check for 0. And what I can do here is factor. So let's go ahead and factor out the 3x, the greatest common factor, and I'm left with x minus 1. Okay, so take a look here. 3x, when is that factor 0, or is it ever 0? That factor is 0 when x is 0, and then this factor is 0 when x is 1. So what do we call these? These are our critical points. Okay, so that was step 1. We found our critical points. Step 2 is to make a number line with those critical points, right? So make a number line, only put your critical points on that number line, and then label your number line f prime on the top and f on the bottom, okay? All right, so now let's come to our factored form. So we've got three intervals, correct? We've got this interval from negative infinity to 0, this interval from 0 to 1, and this interval from 1 to infinity. And if you remember how we solved polynomial inequalities in pre-calc, we're going to basically be doing that here, but we're coming back to f prime, right? This is f prime of x, and I'm using that factored form. So I'm going to be filling in the signs here, positive or negative, on top first, okay? If you need a review on how to solve polynomial inequalities, I posted a video. Please go double check that for review on how to solve polynomial inequalities. Okay, so I'm going to check my first interval here. I'm going to pick a negative number, like -1. So if I plug -1 into this first factor of 3x, that is -3. The point is it's negative, right? If I plug in -1 to this second factor, it's -2. So that's also a negative. And a negative times a negative is a positive. Okay, then I can go with multiplicities. So 0 came from this factor, has an understood power of 1, which is odd. So I'm going to switch to negative there. And then 1 came from this factor, also has a multiplicity of 1, which is also odd. So I'm going to switch signs again. So this should go positive, negative, positive for f prime. Again, if you're not sure where those are coming from, please watch that video, that recap of a pre-calc concept there. All right, so now if f prime is positive, we said earlier, if the slope is positive, then f is increasing, right? So f must be increasing from negative infinity to 0. Now here from 0 to 1, f prime is negative, so f must be decreasing there. And from 1 to infinity, f prime is positive, so f must be increasing there. Okay, let's take a look at the graph and see how we did. Looks good. So this is the graph of y equals f of x, and notice that we're increasing from negative infinity to 0, and from 1 to infinity, and then decreasing from 0 to 1. So it looks good. All right, can you please write this function in your notes, and let's try this next one. So f of x is x squared times e to the 3x. All right. I'm going to let you do step 1, which is let's do the beginning part of step 1. Go ahead and find the derivative for me. Please be mindful, what rules do we need? We need product rule here, right? And then don't forget chain rule when you derive e to the 3x. All right, so here's what I got for the first derivative. I derived the first, held the second, plus reverse it. Again, don't forget your 3 there, the derivative of the inside. So let me clean this up a little bit. We can take out a factor of e to the 3x for sure, as well as x, right? So if I take out that GCF, from this term, I'm left with just a 2. And then in this term, I'm left with this 3 and the x squared. So I'm going to put, the x3x here. Okay, this is never going to be d and e, so to find critical points, all we need to do is check for 0. Again, it's not a fraction, not a rational function. So let's be careful here. You basically have 3 factors. You have e to the 3x, you have x, and you have 2 plus 3x. Okay, so let's go factor by factor. Can that first factor, e to the 3x, ever be 0? It cannot. E to any power can never be 0. E is about 3. There's no way to make 3 0. Okay, even if I make the exponent negative, all it does is make it a fraction, basically. To make it 1 over something. So E, remember, an exponential growth kind of looks like that. So it's got this asymptote approaching y equals 0, but it never actually gets to 0. Okay, so anytime, I know you all don't love E, but it's going to actually make your work easier, because anytime you have e to the x, that's not going to produce any extra critical points for you, which is good because that's less work. Okay, all right, let's look at that second factor of x. That will, of course, produce a critical point of 0. And then that third factor, 2 plus 3x, will give me a critical point of -2 thirds, right? So that equal to 0. All right, from here, what do? We're going to make a number line. Put your critical points and only your critical points on there. Make sure you put them in order. And what do we label our number line? F prime on top f on bottom. Okay, so let's come back now to the factored form of f prime. Okay, make sure you are plugging into f prime. That's important to label so you know where am I going to go back and check. So if I test a number less than negative 2/3, like -1, well, again, that factor is always positive. That would give me a negative, and then this would also give me a negative. So positive times a negative is ultimately going to be positive. And now I can go look at the associated factors with these critical points. So the negative 2/3 came from here, which has a multiplicity of 1, which is odd. So I'm going to switch, and I will also switch at 0 because its multiplicity was odd as well. Okay, so f is going to go increasing, decreasing, increasing. All right, this is example 3. Will you go ahead and write this one and find me the first derivative, please? So I'm getting -2 sine of t. Again, this will never be d and e. That sine wave is nice and continuous. So let's set this equal to 0 to find the critical points. If I divide by -2, 0 divided by -2 is still 0. And look, I'm just going one lap around the unit circle, okay? So that's important. So if I want to know where sine is 0, that would be where the y-coordinate is 0. So I would have to be here and here on the unit circle, right? So that is 0, or 2 pi, as well as pi, okay? So let's do this. In that interval, I basically got those. But now when you make your number line, step 2, don't do arrows, right? Just go 0 to 2 pi. And then my other critical point is pi. Okay, so now let's come to our derivative here. I'm going to box this part. Always box what you're going to come back to. And let's label our number line G prime and G. Okay, so now think in terms of the unit circle, I think is the most helpful. If I go from 0 to pi, that would be from here to here, okay? So sine in those two quadrants, this part here would be positive, right? But then I'm multiplying by that -2. So negative times a positive is actually going to be negative, right? And then let's keep going here. If I've got going from pi to 2 pi, that's quadrants 3 and, that's quadrants 3 and 4. Sine is negative there. So again, this piece will be negative. But I still have that -2 I'm multiplying by. So negative times a negative is going to be a positive. So in this case, G goes from decreasing to increasing. All right, here's my last example for you. Let's say that I give you f prime already. So I've done most of step 1 for you. Okay, so in this case, f prime is the absolute value of x cubed plus 8 all over x minus 2. And remember, critical points are where the derivative is 0 or d and e, right? So here we would have, if I want to check for d and e, I would put the denominator, set it equal to 0. If I want to check for 0, I would put where the numerator is 0, okay? So let's start with the numerator. What x's will make the numerator 0? Definitely 2, right? As well as negative, I'm sorry, not 2. How about negative 2, right? -2 cubed is a -8, and -8 plus 8 is 0, okay? Now, take a look at the denominator. What x value would make the denominator 0? There's my +2, right? So those are my 2 critical points. So when you've got a derivative that is a rational function, something over something, make sure you check both numerator and denominator. All right, you all. I will see you next time.